when I talk about proxy war in the study of consciousness, it's a wink towards my belief that there's a lot going on beneath the surface in a lot of these arguments, and that there is a lot of motivated reasoning. And that in many cases, what people are trying to do is protect something, either a very traditional view or an optimistic view. It's trying to avoid what one might call deflationary theories of things like consciousness, that by making it fundamental or universal, make it less important, less something to get excited about. And I would say my own view of consciousness is quite deflationary.
Chris, thanks so much for joining me. I was trying to figure out a way to start this podcast, and I figured the best way, since it's called Mind Body Solution, was to take your paper, What is a Theory of Consciousness For, and perhaps dissect this a little. Would you like to first start off by telling me, how do you define consciousness? The mind-body problem, perhaps, or what is your understanding of it? And how do you differentiate this from, let's say, other terms like intelligence, cognition, or mind?
Oh, well, that's a very good question. The literature on consciousness is, of course, full of definitions of consciousness, and there are many, many different ones.
Yeah.
So I like to start out very simply and define consciousness as a system is conscious if it's not a philosophical zombie. So a system in this usage is conscious if it has any experience whatsoever. So it could be a system that only feels stress, for example, or a system that only feels some particular kind of sensation. It could be a system that has no memory, no more than a one-step clock. So it could have instantaneous experience, but no remembered experience at all. So with that definition of consciousness, it's clear that I'm a fairly thoroughgoing panpsychist, because and even bacteria can experience stress. I mean, we know that just by looking at their behavior. And, we know a lot of the molecular biology of stress also in such systems. So I like to distinguish that usage of consciousness from lots of other usages of consciousness that assume various kinds of cognitive bells and whistles, like memory. So as soon as you introduce memory, you can talk about things like object recognition. You can talk about things like a sense of self. You can talk about lots of things that we ordinarily associate with our consciousness, but which are much more complex functions than we can expect other sorts of systems to have. Nonetheless, it seems to me that these other kinds of systems are aware of something or other in their environments. So they would count as conscious in the sort of base level sense that I like to use the word. So this is very similar to Philip Goff's notion of consciousness, Galen Strawson's notion of consciousness, etc. It's basically an approach that says there aren't any hard lines when it comes to experience. You can't draw a line somewhere in phylogeny and say everything below this line doesn't experience anything at all, ever. But you can certainly draw lines and say the memory capacity that this organism has is very small, for example, for events. And so its consciousness is going to be very different from ours.
When I think about, there was a paper you wrote, can't remember the date exactly, but you wrote about minimal physicalism. And,
right.
And I think you wrote this with Michael Levin and I can't remember the third author. There were three of you,
yeah.
I'm pretty sure.
Right. Jim Glazebrook.
Yes. Tell me.
Who's a mathematician.
do you want to outline this for us? For all those who don't know what this is. I mean, as you claim that you're a panpsychist, but you have this approach to panpsychism, which you further call minimal physicalism. How would you define this, and how is it different from the average panpsychist? Let's say even Philip Koff, because I've chatted to Philip about this, and your approach is still very different, because you have a different approach to the combination problem than Philip. So what are your thoughts on this?
Well, that paper, which was in Neuroscience of Consciousness in 2021, with Jim and Mike, works from a very simple set of physical assumptions, which is why we called it minimal physicalism. We were trying to make as few assumptions as possible. And basically, we just make some basic assumptions from quantum theory. And the most fundamental assumption we make is the holographic principle, which is a principle in physics that says that if you have a system that's interacting with another system, and the two systems aren't entangled, so their joint state is not entangled, it's separable, then there's a boundary between them, and that boundary encodes all the information that one can have about the other. And in fact, you can define their interaction at that boundary very precisely. If the systems are finite, then that interaction is finite dimensional. So you can write down basically what the systems can know about each other. They can, however, assign any semantics to that information that they want or that they're capable of. And different systems will be capable of assigning different kinds of semantics. So our interest in that paper was really to think about what the minimal conditions for awareness of an environment would be in very simple systems. For example, unicellular systems like bacteria. And to distinguish those minimal conditions from other more complicated conditions that only some systems are going to implement. And two that we picked out in particular in the paper are memory. To what extent will systems have event memory for particular events? And how is that memory encoded? And the other one that we picked out in particular for discussion was space, or spacetime, since the amount of memory you have determines how much time you can remember or how much time you can assign to a sequence of events. But space is different. Whether a system experiences space has a lot to do with whether it can experience objects as distinct from each other and objects as distinct from some background. And if it has the memory capacity to keep track of objects over some period of time and their relations to each other are changing, then, and it's able to re-identify the same object, or at least what it considers to be the same object over many instances of observation, then it can use that information to construct a spatial reference frame in which the object moves or changes with respect to other objects that are not on top of it, but are distinct, detectably distinct. So space is something that gets constructed. And it gets constructed, in our view, in essentially the way that it gets constructed during infancy by all of us, by seeing things and being able to manipulate things and keep track of the identity of things and notice that things can be different from other things. Mm-hmm. That's how we build a spatial reference frame. So those are two particularly kind of consciousness or particular kinds of awareness we describe them in that paper in terms of reference frames, which is physics language, that many systems probably don't have. And systems may have to more or less extents. So we, for example, have very sophisticated and extremely abstract spatial reference frames. But even other vertebrates probably have spatial reference frames that are much simpler than ours, and may even have spatial reference frames that are only two-dimensional.
When I think about your background, and you mentioned that that was a physics term, I think about how your intersection of work, from philosophy to consciousness, from the fundamental nature of reality to physics, there's so many different fields. It's a multidisciplinary approach taking place here. When I spoke to Carl Friston, he mentioned, as we were chatting, this was I think our third conversation together, and I said, a part of my dissertation was it will require a cumulative culmination of collaborative encounters. And then I said, we're perceiving persons assembled by atoms, designed by DNA, manufactured by molecules, forged by fusion via stellar supernova. And then Carl was like, you know what? The person you should talk to is Chris. Chris Fields is the guy you should talk to. He'd love that. Do you like that, first of all? And why do you think it's so important to have this cumulative culmination of collaborative encounters? I love illustrations. It was part of my thing.
I like that way of putting it, actually.
It's a great one. When I wrote it, I thought it was pretty cool.
Yeah. And of course, Mike Levin has emphasized over and over and over that intelligence is collective. So, and that intelligence is based on communication. So, collaborative encounters is a nice way to put that.
Yeah, Carl was like, "Have you spoken to Chris?" Not yet, but soon.
So, yeah, I think what you're referring to here is the quite large question of why we have complexity, why we see complex systems at all. And, since you've talked to Carl, you've probably talked a lot about the free energy principle. And the free energy principle is basically an attempt to answer that question, to say, why do we have complex systems? And sort of a simple way to describe the answer that the FEP gives is that complexity at the level of a large system is a way of simplifying the prediction problem of each of its components. So if you're a free living organism and you're just out in the wild, you have to cope with a lot of uncertainty because you're exposed at all times to this open environment. And if instead of that, you're part of some multicellular system, then you're in an environment that's much simpler, that doesn't change nearly as often, and so is much more predictable. So complexity at this large scale can lead to simplicity at smaller scales. And that's essentially why the free energy principle predicts that you'll have complexity, because simple systems will build complex environments in order to make their lives easier. And when we think of systems here, we can think of things like single-celled organisms, for example. Microbes really like to live in microbial mats. Why? Because it's a much less complicated environment than the rest of the world. But you could, a little bit metaphorically, try to extend this to, why do protons and neutrons like to stick together in nuclei? Well, it makes their free energy smaller.
And ultimately, that is the goal, is to sort of minimize that energy that you're talking about. So how can we get to the, well, let's rephrase it in the sense that how can we get something done with the least amount of work possible?
Right.
Yeah. When you started this journey, because as I mentioned, you're technically a polymath in this case, in the sense that you're able to understand and add and contribute to various different fields. How has your academic journey shaped your view on consciousness? A question I often ask the guests when I start this show is, and I actually forgot to ask you this, but what is your philosophical history of the mind-body problem? When you think about consciousness and the mind-body problem, what's the story that you tell yourself? Because it often gives us key pointers as to how you've become the panpsychist you are, or shaped this view.
Oh, that's a difficult question.
I know some guests decline to answer it.
Yeah. Well, I started my academic journey as a physicist, as an experimental physicist. So, someone who played around in machine shops and did a lot of plumbing. And I started kind of studying philosophy at about the same time. I had a minor in philosophy actually as an undergraduate. But my introduction to philosophy was through logic. And from there to 20th century philosophy and sort of late 19th century philosophy. So I didn't have the usual kind of academic route that starts in the ancients and goes forward. But rather, it started with fairly contemporary, for that time, philosophy of language and philosophy of mind and philosophy of logic and that sort of thing. So a lot of that was very physics oriented and imbued with the usual kind of physics envy that you find in academia. So that was not a very good environment for becoming a dualist, for example. So I would say that I probably started out as a fairly uncritical garden variety physicalist in the usual philosophical meaning of that term. But nonetheless very worried about that approach to things because it's based on classical physics, and so it's wrong in a deep sense, and it can't explain all sorts of phenomena. So I've always been interested in the idea that there's more to biology, there's more to psychology, et cetera, than the kind of classical local mechanisms model that's on.
And when you wrote that paper in 2021, when you said, what is a theory of consciousness for? You further went on to ask, what does it mean to explain consciousness? And you also described the consciousness war that's going on, and you called it the proxy war. What did you mean when you said all these when you asked these fundamental questions?
Yeah. Well, now this whole consciousness studies phenomenon has blossomed since the 70s, really, and has really blossomed since the 90s and the invention of neuroimaging. And so one has a real mix of players in this area, from traditionally trained philosophers to medical people who are interested in, what's happening when they give a patient anesthesia, and what are they really aware of independently of what they can behaviorally report. And what's the difference between experiencing something and not remembering it and not experiencing it at all?
Yeah.
And is that difference important, medically or ethically or something like that? So that's a different set of concerns from the kind of traditional philosophical concerns. And then you have the whole question about consciousness in artificial systems. And uh, then the question in the biology of consciousness in basal organisms, or even very complicated organisms like plants, or even ecosystems, for example. So there are many different points of view that bring very different interests to this debate. And I think also bring with those different interests, different motivations. So if you look just at physics, there's a tremendous amount of effort spent by many people trying to protect our classical intuitions with theories like, objective collapse of the wave function, whatever that means. And, endless debates about whether entanglement is a real phenomenon. And these are philosophical arguments that are really about protecting something, protecting kind of folk intuition about how the world works.
Mm.
And I think the same can be said in the field of consciousness. I mean, people are in general folk dualists, if you will. And the culture has a lot riding on that. So our culture has a lot riding on particular traditional notions of free will that are
Yes.
very problematic from the point of view of classical physics. And so there's a lot, I think, of
religious. There's also a lot of religious attachment to it as well. I mean, we
yes,
really are culturally stuck within this framework.
right. So there's a lot of motivated reasoning going on, often below the surface. And so when I talk about a kind of proxy war in the study of consciousness, it's kind of a wink towards my belief that there's a lot going on beneath the surface in a lot of these arguments, and that there is a lot of motivated reasoning. And that in many cases, what people are trying to do is protect something, either a very traditional view or an optimistic view, which Philip Goff is I think clearly trying to protect.
Mm-hmm.
And often it's trying to avoid kind of what one might call deflationary theories of things like consciousness, that by making it fundamental or universal or something like that, make it less important, less something to get excited about. And I would say my own view of consciousness is quite deflationary.
Well, so I've broken this conversation up into 3 pillars almost. One is on physics, then consciousness, then a little bit on free will. Let's start with the first question. I wrote, in your paper, you discussed the implications of quantum mechanics and the fundamental nature of reality in most of your work in general. Can you explain how you see quantum mechanics shaping our understanding of time and space in the context especially in the context, actually, of a non-classical view of reality?
Hmm. That's an interesting question. I mean, my view of quantum theory is that it's basically a theory of measurement. It describes how some physical system interacts with its environment. And it describes it in terms of information exchange. So quantum theory is, in a sense, a theory of communication, or it allows us to rephrase a theory of physical interaction in terms of a theory of communication. And it provides us with a very natural way of talking about the semantics that each of the communicating parties assign to the information that they give and receive. And it tells us very clearly that the semantics of the two interaction partners don't have to be the same. And in fact, if they're not entangled, they in general won't be the same, at least in detail. So we can use quantum theory to turn physics into something that looks like the theory of communication. So it starts to look very cognitive. You know, we can talk about things like semantics in a purely physical language, the language of reference frames or basis choice. So what quantum theory does for us is start to dissolve the boundaries between disciplines, which is something that I'm very attracted to. I mean, I think the boundaries between disciplines are more constraining than they are helpful. They're part of the problem, not part of the solution.
I agree.
So what does this tell us about space and time? Well, one thing it tells us very clearly is that space and time play different roles in the theory. And time is related to persistence and memory. So you can't keep track of time unless you have memory. So time and memory are basically interdefinable. And identity. So one can't determine that an object has identity over time without having memory. So without having a sense of time. So without having a reference frame for keeping track of time. And so all of these concepts that appear different at first glance, memory and time and persistence and identity, turn out to be ways of talking about the same thing. And none of them involve space. But if you have a bunch of different things, as we were discussing earlier, and you want to talk about their identities over time, then you sort of need this concept of space because it provides you with a place to put the thing at different times. So one can also think of space as a resource for memory or as a resource that gives you redundancy because
Is it almost like
I
a
can,
storage unit at that point?
Yes, yeah. I think that quantum theory at least encourages us to think about space as a memory structure of some kind. And this gets worked out in great detail in quantum gravity research, where many, many different people are pursuing many different approaches to describing space as an error-correcting code. And an error-correcting code is just a redundancy resource, a kind of memory. So quantum theory encourages us to think of space in terms of memory, in terms of what we can do with space. And in describing a system that is communicating with another system, that communication, describing that communication situation just requires that you have a state space for this, which is different from a physical embedding space. So we can do all this quantum theory stuff without talking about an embedding space at all. Although if you take undergraduate quantum mechanics, you're going to start out with quantum theory in spacetime. But you don't need to put quantum theory in this embedding space. And since you don't, then if you want to talk about the communicating systems employing space as a memory resource, then you have to assume that those systems have the computational capacity to encode the sorts of reference frames and the sorts of reasoning that space makes available. So, which are symmetries of object identity. They're transformations in space that allow you to preserve object identity, like moving something from here to there or rotating it, giving it a boost in relativity theory, accelerating it. So quantum theory encourages us to think about space in this very highly non-classical way.
Mm. And when you think about the wave function in consciousness, how do you interpret the wave function in quantum mechanics with respect to consciousness? Do you align with the idea that consciousness plays some sort of role with collapsing the wave function, or do you see it differently?
Well, I think the idea of collapse of the wave function is not a very productive way to think about things, actually.
Mm.
And here, I think one of the pioneers who's worth mentioning is Chris Fuchs and his approach of quantum Bayesianism, or as he calls it, cubism. I don't know whether you've talked to him or not on your
I haven't, but we've
program.
chatted by email. But
yeah, he would be a very interesting person to talk to.
Mm.
And he emphasized almost 15 years ago now that when we think about quantum states, we're always thinking about the inferences that some agent makes on the basis of measurements. And this idea goes back, of course, to Bohr and Heisenberg and the so-called epistemic view of the quantum state. But if we want to start by describing a system, we have to, of course, assume some quantum state of whatever universe it is that we're talking about in order to get anywhere, because we've got to write down a state space for this thing.
Mm.
And if you're talking about a universe, an isolated system, then clearly there are no observers involved, right? There's nothing outside the universe looking at it. So when you postulate this state space, or postulate a state of this universe that's evolving through time, you're not in this epistemic framework. You're in a completely stipulative framework where you treat this state that you've postulated as an item of your ontology. But then immediately you talk about dividing this big universal state space into two pieces. And then you have two observers. And each of them is measuring the state of the other. And it's measuring it by interacting with this boundary that separates them. So the states of the two systems are, in a deep sense, invisible to everybody, right? Alice's state is invisible to Bob, but Alice's state is also invisible to herself, to Alice. What they actually see are the pointers on their detectors. Right? So what they actually see are observational outcomes. They never see the state. They infer a state. And a quote, observed state is really just a set of observational outcomes. And this is the argument that Chris Fuchs makes, and I think makes very well.
Did you see other theories of consciousness that entail quantum mechanics? How do you perceive some of them? Let's take, for example, someone like Roger Penrose. I mean, you spoke about anesthesia earlier, the fact that when someone is out, well, I mean, are they forgetting? Are they actively losing consciousness? And then we've got someone like Roger Penrose and Stuart Hameroff. Yeah, and Hameroff, I mean, obviously they're talking about ORC or R. What are your thoughts on this quantum theory of consciousness? Just as a side note, before we move on.
Well, I've never really understood the motivation for OR, and I've heard many talks by both Penrose and Hameroff, and I think that Hameroff, for his part, is clearly right in treating molecules quantum theoretically as opposed to purely classically. Mm-hmm. I mean, at some level of chemistry, you're forced to do that. I suspect you're forced to do that at larger scales than are often recognized or are often assumed. Right? It's often the assumption that even macromolecular structure can be described completely classically, and you can get away without it. Mm. It's no big deal. I suspect we'll find that isn't right. That's too much of an approximation. Mm. So, and Stuart is also obviously right that there's a lot of information stored in microtubules. I've never understood why there should be any connection between the fundamental structure of space-time and the structure of microtubules. And of course, given what I just said, I don't even believe there's a fundamental structure of space. Right? I think that space is a construct of observers, not the other way around.
While we're on that, if you're talking about observers, just by the way, I spoke to Joe McFadden. I'm not sure if you're familiar with his work, semi-field theory. And even he, I mean, so someone who does talk about quantum biology, because there's so many different ways that biology is using quantum mechanics in its mechanism of functioning. For example, certain plants and photons and the way they react. Even he doesn't agree with that theory. But when you're talking about observers and you think about the role of the observer in reality, what comes to your mind in terms of quantum mechanics? How do we reconcile the observer effect that exists in terms of physics? For anyone who does not have a history in physics and has this layman's version, because a lot of people tend to think, especially if they're not physicists, and they hear about the observer effect, many people seem to assume that their effect on reality is greater than it might be, perhaps, because you're able to fundamentally change the particle state merely by perceiving it. What are your thoughts on that, Chris? Or am I interpreting that incorrectly?
Well, we talked about folk psychology a little bit back. I mean, we all have a folk physics.
Yeah, this is what I call folk physics.
Right, and it's a kind of classical naive realism. Right, we think that there are objects out there which are completely observer independent and that are just going about their business. And one can kind of force this worldview into quantum theory. but one has to go through all sorts of machinations, and one's eventually forced to some sort of theory of objective collapse and a very hard quantum to classical divide and on and on and on. And it becomes virtually impossible to talk in any sensible way about observation.
It is.
So what that suggests to me, at least, is that the whole framework is wrong, that the idea of completely observer independent objects should be abandoned. And that when we think about sort of our shared world, we're thinking about a structure that we've built by communication, not just between humans, right? Between lots and lots of different systems. And so when we think about our actions on that shared world, the locally observable effect that we have is something that we have to negotiate with the other observers who construct that shared world with us. But our long-term side effects of actions are things we can't predict.
Mm.
And can't be predicted by a Turing machine, for example. So this isn't just an intractable problem, it's an undecidable problem. To say, is this future event in any way connected to my action at some earlier time? And if you take the idea of a light cone from relativity seriously, then the causal effect on anything encompasses the entire past of the universe. And you have beautiful results like the Conway-Koken theorem that tell you that even the entire past of the universe cannot completely determine the behavior of any single object. I mean, the behavior of an electron. So this idea of local determinism, which is the idea that, I can make some particular thing happen, is just inconsistent with our physics.
So what would you then say is free will? How would you classify this, define it, or incorporate it into reality?
I actually like the Conway-Koken definition. Their definition is freedom from causal determinism. And another way to think about this in a more purely quantum theoretic way is, if I'm an agent and I'm interacting with my environment via some boundary, then that boundary is encoding all the information I can have about my environment. But the way I interact with that boundary involves choosing a measurement basis, right? And that choice for me is free. And my ability to make that choice is a requirement for my not being entangled with my environment. So it's in that sense, freedom of that particular kind is a requirement for being an agent. Now, I mean, this raises another issue, which is nothing I can do I can't demonstrate observationally that I'm not entangled with my environment.
Yes.
So I can't I can't demonstrate observationally that I have this freedom. But if I'm an agent and I am distinct from my environment, then I have that freedom.
Mm, mm. Well, on that note, how does this view, or your view in consciousness as well, and reality, impact traditional ontological or epistemological questions? Like, how do we solve certain existing paradigms, meaning, teleology, purpose, taking it a little too far perhaps, but I'm just curious.
Well, and the easiest part of the answer to that question is negative. Right? Within this framework, one can prove that a whole lot of things are undecidable, not just by humans, but by any computational system. So one can establish lots of things that we don't know and can't find out. So we don't know that we're distinct agents. We don't know that we're not entangled. We don't know how we work. Right? We don't know what our internal state is. We don't know what our internal processes are. There's no way for us to find those things out. So we have all of these kind of no-go results or undecidability results. And where does that leave us? It leaves us constructing theories of various kinds, including quantum theory, right? It's just a theory. And it's the simplest theory we have, but it is a theory. And in the context of that theory, then we can describe ourselves. And when we do so, we realize that even if we're not entangled with our environments, there is nonetheless this universe that we're part of, and our environment's the other part of it. And that universe is doing something or other. And we can't determine what it's doing because we can only measure we only have the information encoded on our boundary, which is, a tiny fraction of the information in our environment or the information in us. So we don't have much to work with. So we can't tell what the universe is doing. But we know it's doing something, at least in the context of this theory.
The reason why I asked that was when I chatted to Mike for the third time, I recently had a conversation with Terence Deacon, and their work intertwines very well, even though they have very different views about reality. And we were scheduling a conversation between the two of them, and I thought about their teleodynamics and the fact that they both have some sort of teleodynamics from their theory. So I've now become curious with this idea. Every person I have on the show, I'm going to ask them, like, what is the teleological outcome, do you think, that comes from this view, if any? And is that even a plausible question? Because can we really predict what the future holds?
Yeah, I think in a sense it's not a plausible question. We all like to pretend that we know much more than we know, or that we can know. And
it's almost like assuming we are Laplace's demon in that sense. And that we can just predict everything that's going to happen because this is such a deterministic universe, which is very unlikely.
Yes.
But that's what most theories tend to do in the first place. Okay, but
Right.
Okay, let's leave teleology aside. From your view of panpsychism, Chris, how do you define it? How do you see your panpsychism, and how is it different from, let's say, Philip's or someone else's? And how do you solve the combination problem? If you solve the combination.
I certainly in my response to Philip's book, what is the theory of consciousness for? One of the lines of criticism was his focus on the combination problem
Mm.
and his, I think, characterization of the combination problem. And I think my view of that very traditional problem is that it's ill posed, or it's not stated in the right way. And so it's stated in a way that renders it unsolvable from the beginning. So what's the kind of canonical statement is that I, for example, am a collection of cells, and all those cells are having experiences. How do all those experiences combine to be my experience? And my answer to that would be they don't, right? My cells, each of my cells has an environment. It experiences what's encoded on the boundary with its environment. Its environment bears no relationship to my environment, or no simple relationship. Right? My cells are surrounded by other cells. They talk to other cells. They talk in cell language. They don't know anything about laptops, for example.
And not just human cells. I mean, you've got bacterial cells. You've got,
right.
Yeah.
And you could make the same point about functional networks in the brain, right? Their environment comprises other functional networks. They don't know anything about laptops. And moreover, I don't know anything about their environments. I can't have their experiences. We're just different systems. So what's actually going on here? I think what's actually going on here is we have a complex system, and we realize that we can draw all sorts of boundaries inside that system. So I'm a complex system, and you as a theorist can draw lots of boundaries inside me, say the boundaries around all of the individual cells. And so you can characterize all of these interactions that are happening in me, which, if you're a panpsychist, involve experience. But that experience is dependent on how those boundaries were drawn. And if you want to characterize my experience, then that's experience that's determined by my boundary, not those boundaries inside me. It has nothing to do with the experience that's encoded on those boundaries inside me. So from that perspective, this traditional notion of the combination problem, or the traditional formulation of what combination is just misplaced. What my cells do is implement my capabilities for having experience, right? They're like the chips in my laptop. They implement the laptop's ability to do what it does, and my cells implement my abilities to do what I do. And implementing those abilities involves them having the experiences they have, but they're not thereby having my experience, and I'm not having theirs.
I think that's where it becomes a bit of a problem, because we're almost looking, when you define a combination problem, when all is combined, you need to have some sort of an outcome. So, and it becomes this Ian Vitale type thing. I always talk about how the moment we say that, we're making consciousness so very special, but perhaps too special in a sense. And I think that does become a problem, because you can have a spectrum of intelligence, of conscious beings, let's say, or cognitive beings. But the moment you say, how do you bring them all together to form this thing, you're almost talking about a spirit. Do you agree with me with that, or do you think that that's not true?
Well, I'm not sure what you mean by spirit here, but I think you are.
Okay, well, not spirit. Let's say an inexplicable, almost Ian Vitale-like entity that is essence-like and has no explanation.
Possibly.
I don't mean that in a bad way.
In a sense, if one assumes, let's take a simple case.
Mm-hmm.
Let's say, what would it be like for me to actually have the experience of some cell in my liver? Right?
Yeah, like an islet of lung. No.
Right. So I would have to be embedded in a certain kind of electrochemical environment
Mm-hmm.
and bioelastic environment. Now I could kind of gen that up with some sort of virtual reality system based on a theory of what's going on in my liver. And this is a plausible tool for teaching people biology. I'll try to have them experience what's in a liver cell using their sensory apparatus to the extent that they can. And one can hypothesize that would kind of involve taste, right? The environment would have a certain saltiness and a certain acidity, and it would involve electrical shocks of one kind or other, and would involve my body being pulled and twisted in various ways by the other cells that are around me.
The effect of alcohol coming in disrupting.
Right. Right. Yeah, I could suddenly feel a lot of stress, for example. So one can try to tell a story like that, but it's in a sense a very technological story, right? I have to build a whole device to try to do that, and I have to have an entire theory to even think about building the device. So there are many, many, many inferential steps and then some technological steps between my experience and my attempt to replicate the experience of one of my components. It's not a process that just happens. So when you said a kind of an inexplicable thing, I think there's this sense often that I have a knowledge of my internal structure that I can't have except theoretically.
It's almost like when I'm saying inexplicable, I should actually be cognizant of the fact that most of the ongoings right now in my system is inexplicable.
Yes.
To really have assumption is actually a problem. No, I understand exactly what you mean. No, that is a very good point. When I spoke to Carl about this, I asked him. I said, "Look, because Philip, for example, he says that the most logical conclusion he can draw is panpsychism in terms of a theory of consciousness. But his second most likely conclusion would be illusionism." And when I spoke to Carl about this, I said, if you think about free energy principle, if you think about Markovian dynamics, Markov blankets, and maybe active inference specifically regarding Helmholtz, and you think about the way a human perceives reality, take in enough prior information. And if your prior information is consistently telling you you are conscious, you're a conscious being, you think, you perceive, you live in a certain way, you perceive reality as true, the most likely posterior outcome is going to be that you have this sort of essence-like qualitative qualia experience. It's almost impossible for you to then deny this to yourself because you've built up so much prior confirmation bias to this that you have to make this decision. Carl says when you phrase it that way, then illusionism is very likely. But it's I often say, look, when I think of illusionism, I don't think of it as saying consciousness doesn't exist. I think of it more as thinking of how other theories of consciousness have a problem in a sense. So it's not really saying that it doesn't exist. And I think a lot of illusionists are starting to say it that way now. And I believe that Dan Dennett, towards his last few years, merely interacting with Mike as much as he was, talking about these different ways of seeing cognitive, proto-cognitive elements, I can see a lot of illusionists becoming panpsychists because they can see that this is just a spectrum of mind over time.
Yeah, I agree. I would like to see it go that way, actually. I think that it's very difficult to be an illusionist who claims that experience doesn't exist. There's no such thing as even instantaneous experience. Right? Yeah. That just doesn't make sense to me, as many people have pointed out. Oh, not just me. But I think it's very easy to be an illusionist about, say, the self, because virtually everyone now sees the self as a construct, as something that we make up.
Yes.
And I think it's easy to be an illusionist about the mind, right? The mind's something that we kind of make up. It's a story we tell ourselves about the continuity of some set of beliefs or something like that, as you were describing with your imagined conversation with Carl. So I think there's a convergence point that agrees that experience exists and that it's probably fundamental, which means panpsychism. But that many of these other ideas that we traditionally associate with consciousness are constructs. And they're very useful constructs, but they're models that a system uses to make sense of its world. And the key construct, in a sense, is memory. Right? We can't prove that we have memories. We can't prove that we're not Boltzmann brains.
And that becomes a big part of what you talked about earlier with anesthesia. I mean, a lot of us, we still don't know, even me as a medical doctor, we're still not sure if it's just that we've lost consciousness or forgot what happened. We really don't know.
Yeah, I think it's an interesting kind of ignorance to have.
It is. Curious.
But it's probably a kind of ignorance that we have to have.
Yeah. No, I agree. What are your thoughts then, Chris, on idealism?
I guess I tend to think that the realism-idealism debate isn't very useful. And again, I'm motivated in this by this basic kind of quantum information theoretic type of model. The simplest thing we can assume is some system that's isolated, so it's not observed, and we can divide it in two and talk about observation. And if we do that, then it's clear that there's something that's being observed, right? The environment. That's what we're interacting with. And the environment isn't in our minds, but everything that we claim to know about it is, right? We don't have any actual access to its state other than some information that's encoded on a boundary. So, in a sense, traditional realism and traditional idealism both get something radically wrong, right? Traditional realism says that we have access to all these observer independent facts, and we don't, because there aren't any. And idealism, at least in a kind of simple traditional form, says that there's nothing going on but belief. And that dodges the question of, so how is that implemented? And if we take this very simple sort of physical model and say, well, what do we have to assume the universe is like in order to cut it into these pieces and talk about observation and communication and all of that? The answer is we don't really have to assume anything. I mean, it's fine if we think of the universe as a big bag of spins. Right? It's just a bunch of qubits. And the whole story can be told without assuming anything else.
The funny thing is that when I spoke to Carl, Mark Solms, I mean, Mark's in Cape Town, I'm in Cape Town. So I see all you guys doing this work. And it's so intriguing to see so many different types of scientists and philosophers coming together. And when I spoke to Mike about it, I said it's almost like the Avengers of Mind getting together and trying to defeat Thanos, which is consciousness. You know, it's pretty cool to see this come together. What are your thoughts on this really multidisciplinary approach that's occurring in 2024 and just prior?
I think it's a great thing. You know, I see a lot of boundaries between ways of thinking collapsing, and people talking to each other that wouldn't have been talking before. And you know what you're doing, for example, encourages this and contributes to it. So I think you're doing a very good thing in terms of having conversations with a large number of different people from different backgrounds in a kind of common language. So, you know, we all write papers in our own languages, and then we try to read them. And probably physics is one of the harder disciplinary languages to learn. But it's very good to try to formulate these ideas in just ordinary language.
No, that means a lot to me. I mean, and it's exactly why I started this. I was telling you earlier, I mean, started off as a folk dualist, became an emergentist, and then became an illusionist because I started to think that this is where we're putting too much emphasis on this. And now I found myself just ontologically agnostic, and that's what I call myself. I say, look, regarding consciousness, I just don't know, because I've chatted to so many great minds like yourself. Many of you guys contradict each other in so many different ways, that complement each other in so many different ways, that it's so difficult for me as the host of this podcast. And this podcast has played a huge role in that, even though I've done my own academic work on it. But it's fascinating to see, and that's why I was curious to know what has been your journey from you're a panpsychist now. What's changed over time, and if any, has there been any change in your view on consciousness?
Yeah, well, as I said, I when I was in graduate school in the 80s, I would probably have characterized myself as sort of a naive functionalist or a naive physicalist. But with these worries about how this way of thinking connected to physics, really.
Yeah.
And I would say those worries didn't start to get resolved for quite a long time. I mean, I kind of abandoned much of academia for at least a decade, and didn't come back to it until about 2010.
And since 2010, you've churned out tons of papers.
Well, I met Mike very shortly thereafter, and he introduced me to the whole basal cognition way of thinking, which seemed very intuitively compelling to me. You know, I suppose I've always had a soft spot for trees and so on, as being fellow entities in the world.
I tell people all the time, when you watch trees long enough, you can definitely see intelligence in motion. But you just need to actually have the capacity of time on your side to witness what's really going on. And that's where what you were talking about earlier comes in. Time is so relative. We really need to see trees over millions of years to know what's really going on here. It's not our just average lifespan.
Yeah, yeah, yeah. That's a very good comment to make. We are very limited by our ways of looking at the world.
Yeah, these heuristic adaptations and these biological constraints really do limit us overall. So that naive realism we all share is very misplaced. But yeah, Chris, thanks. It's been such a pleasure. From your side, before we conclude, is there anything about consciousness, reality, the mind-body problem that you feel you'd like to just let us know your view on, or something you haven't explained or expressed properly? The floor is yours.
Not that I can think of. You've hit a lot of the high points in this conversation. If I would say one thing, it would be that I think there's a lot to be said for making the smallest number of assumptions possible and the simplest assumptions possible, to try not to build more complexity unless it's really necessary. I think I also have a very kind of ambiguous relationship with or feeling about intuitions. Everything we get right comes from our intuitions. And the universe sort of tells us, this is a good idea. But everything we get wrong comes from our intuitions too. And so it's very difficult when faced with an idea to decide whether it's a good idea or not. And I guess as you were saying earlier, being willing to change one's mind is an important thing.
Yeah, no, for sure. And I think this podcast plays a huge role in that. It's for me to provide the greatest thinkers. You guys provide everyone with the most information possible to make the most informed decision possible.
Well, great. It's a good thing to do. I appreciate it.
Chris, it's been such a fascinating conversation, and there's so much more I want to ask you, and I hope we do have, just like Carl and Mike, many rounds in the future. It's been such a pleasure. Thank you so much.
Well, thank you. This has been a very nice conversation.
I've enjoyed it.
I enjoy thinking about these kinds of questions.